we came in.
MODO. Morsels.
Pink here with a not-so-quick morsel which looks at one way to build the wall in MODO. There must have been a door there in the wall This morsel explores the use of arrays and a new and quite well hidden feature of the particle generator, which converts array positions into particles. The first thing we will need is a brick. A cube 2 meters by 1 meter by 1 meter will suffice. Now we need to replicate the bricks. I'm going to do this using an array generator, which replicates its geometry in a regular grid. So create a new mesh and call it grid. Add a merge mesh and pull in the brick. Add an array generator and set the dimensions to your liking. I'll go for 40 by 30. Set the dimensions to match the size of the brick, either by putting the numbers in, or if you're a good soul, by rigging it back to the brick. You can see what I've done. Well, that is a wall, I suppose, but not a very good one. I would rather not stand next to that in a high wind. I'm going to fix that by using an array operator. Let's replace the merge meshes with a vertex operator. This creates a single vertex at each grid point. What we need to do is shift along every other row of points by half the brick size. This is where the array operator comes in. First, we need to convert the vertices into an array using the particles to array operator. When the array is selected, you will see markers showing the positions of the array elements along with their indices. Then we can feed the resulting array into an array operator. The array operator will iterate over each of these elements. Add the index and both the element channels to the operator and separate out the output element. The names for these could be more helpful, methinks. To identify the elements that need shifting, we need to do some simple sums. We could create a network of nodes for this, but the expression node is a more compact and less bothersome way to do it. It's also easier to correct if we make a mistake. If we divide the index by the x count, which is 40 in our case, and truncate using the floor function, the result we get will be a row number. All we need then is to see if this number is odd or even using the mod function. An even number mod 2 is 0, an odd number mod 2 is 1. The elements will be of type vector 3, which is different to the vectors we normally manipulate in the schematic. Use a vector 3 to vector node to convert. Now it's just grunt work. We will need a vector add to add our offsets. I will use a scalar vector multiply to calculate those offsets using the expression result. Remember, this will either be 0 or 1. So the offset for an even row will be 0, and for an odd row it will be the values that we set in the vector input of the scalar vector multiply node. We will need to convert the result into a vector 3 before we feed it back into the array operator's output element. Phew! Okay, so now we have an array that is looking more like the layout of a conventional wall. We need to convert this into particles so that we can replicate our bricks at those positions. Here is where the particle generator comes in handy. Add a particle generator, and notice it has a user array input. To make use of this, change the particle generator type to user array. Plug the generator into the replicator and add the brick as a prototype. And the wall is complete. As an added bonus, the array operator also has a remove channel. We can use this to selectively delete parts of the wall. In this example, I am using a texture fall-off to create some random holes, but you can use any fall-off or indeed any expression to decide which bricks to delete. If you want to manipulate the wall further, then create a new mesh and use merge meshes to copy the result of the replicator. You can now add bends and twists, etc. to your heart's content.